By using de Moivre's theorem and your answer to part A, show that 5 theta is equal to 16 times sine to the power of 5 theta minus 20 sine to the power of 3 theta plus 5 sine theta. All right, so let's do that. So the first thing we need to do is we need to equate these two things, right? So we need to equate what we had previously in part A, which was cosine theta plus I sine theta to the power of 5. We need to equate that to cosine 5 theta plus I sine 5 theta. The first thing we need to do then is we need to equate the imaginary parts here. So going backwards, right, the imaginary part over here on the right is sine 5 theta, because notice that it's I, there's an I in front of it, so this is an imaginary part, and this must be equal to the imaginary parts that we had previously in the previous part of the question. So that's going to be equal to 5 cosine 4 theta minus 10 cos squared theta sine cubed theta plus sine 5 theta. And this we just get from the imaginary part of the other question there. So we need to equate those two and then figure out what that's going to give us. So overall, is there anything we can do here to make this a little bit simpler? Well, we can substitute something to get rid of cos theta, because if we notice what we're trying to get something only in terms of sine thetas. And one thing that we know is that, recall that sine squared theta plus cos squared theta is equal to 1. And so that means that cos squared theta is equal to 1 minus sine squared theta, like that. So therefore, every time I see cos squared theta, I'm going to exchange it for 1 minus sine squared theta. So 5 times 1 minus sine squared theta to the power of 4, or sorry, power of 2 here, because we already have cos to the power of 4 theta there. And then minus 10 times cos squared theta, which again is just 1 minus sine squared theta, and then sine cubed theta can stay as is, plus sine to the power of 5 theta can also stay as is. Now I'm going to expand the bracket, so we're going to get 5 times 1 minus 2 sine squared theta plus sine to the power 4 theta minus 10 plus sine squared theta when I expand these brackets, and then just sine cubed theta plus sine to the power of 5 theta. Okay, and now we're going to continue with that. So we're going to get 5 minus 10 sine squared theta plus 5 sine to the power of 4 theta minus 10 plus sine squared theta sine cubed theta plus sine to the power of 5 theta. So now if I collect like terms at this point, we're going to end up with 16 sine to the power of 5 theta, and then minus 20 sine cubed theta plus 5 sine theta, and there we go.